Welcome to the POI demonstration of LUO converter based BLDC motor. In this POI we are using voltage source inverter and Arduino Atmager 328 microcontroller and the rectifier and step down transformer, and this is the LUO converter, and this is the IR sensor and BLDC motor, and this is a PIC microcontroller, and this is the LCD display. And also we are using a port. So here we can see the where it will be vary the values, or we can call as a port. So that will be interfaced with the Atmager 328 microcontroller. So the main purpose of this project is to control this BLDC motor and how to calculate the RPM using this IR sensor. So coming to the power supply, we are providing the power supply through this power cable. You can see here it will take 230 volts power supply. That 230 volts power supply will be given to the step down transformer. So this is the step down transformer which takes 230 volts input and will give and will step down up to 12 volts AC with the 2 current. That will be given to this KB10 rectifier. It takes the 12 volts input and will convert into 12 volts DC output. It is taking AC input and it is converting DC output. That it will be generate a pulsating DC. That pulsating DC will be purified by this 1000 microfarad capacitor. So after that it will produce a pure DC 12 volts. That pure DC 12 volts will be provided to the LUO converter. So here we can see we are providing from this one so to this LUO converter, and also we can see there is a voltage regulator called 7805. It will take the 12 volts input and it will convert it will step down up to 5 volts input, 5 volts power supply. That 5 volts power supply will be utilized by this PIC microcontroller. Sorry, this is not a PIC microcontroller, it is a Atmager 328 microcontroller, and also we are providing the 5 volts power supply for this port 2. Now coming to this LUO converter. So this LUO converter main purpose is to it will produce a low ripples. So we can control this BLDC motor using this source voltage inverter, but there is a one disadvantage, that it will produce sometimes it will produce a DC power supply to this BLDC motor, but sometimes it will produce a high ripples that may cause voltage lagging. If the voltage lags, then the power supply will be down, the speed of this motor will be also down. In order to remove that disadvantage, or the we need to get a good power supply, we are using this LUO converter. So it will be produce a low ripples voltage that will be provided to this inverter board. So we can see it is converting that giving the low ripple voltage, that it is taking the DC 12 volts here and is converting low ripple voltage DC that will be given to this inverter. So inverter generally converts DC to AC. So it is taking the AC and converting to it is taking the DC and it is converting to AC. So it is taking the low ripple DC. That low ripple DC will be converting to AC. That AC will be provided to this BLDC motor. And also we can see these are the connections. So, and also here we can say LUO converter which is given pulses using this microcontroller. At the same time we are giving the pulses to the inverter board also. That inverter board will be giving the pulses using this microcontroller. So it is providing the pulses to the inverter board, at the same time it is giving the pulses to the LUO converter. So in this way it will be produce the low ripples. The low ripples will be given to this voltage will be given to this inverter. The inverter give the voltage to the BLDC motor to operate. And coming to this section, it is a RPM section, rotation per second. So it will calculate the rotations using this IR sensor, and also we can see this is a PIC microcontroller, so which is interfaced with the and also using a LCD display which is interfaced with the PIC microcontroller. So these two microcontrollers are different. So this is a PIC microcontroller and this is the ATmega 328 Arduino controller. So now for this one we are providing the adapter. It takes 230 volts power supply. It will give 5 volts of DC. That 5 volts of DC will be given to this PIC microcontroller. So first of all we need to give the power supply for this board. Now I am giving the 230 volts power supply. So we can see the BLDC motor sound which is initialized and is ready to run. Now we are providing the power supply to the RPM board. So if we rotate this pod, so we can see it is rotating, and also it is here we can see the IR sensor is in active. So if it is not detected, so it will be detect the object. So here we can see there is a white paper which is detected by the IR sensor. So based on this white paper, it will be calculate the rotation per minute. That will be given to this A4 of this microcontroller pin, and also that will be displayed on the LCD display. Now I will show you the display over here. So we can see here. Now I am increasing the port value. So we can see here 95 RPS rotation per second. Now I am again increasing. So this is the maximum speed of this BLDC motor, and also now I am decreasing the BLDC motor, and we can see the RPS rotation per second, and also we can upload the sound also here. I am totally downing this, so we can see RPS is 0. So in this way this point will be works. Thanks for the watching.